if a seed is planted, it has an 80% chance of growing into a healthy plant. If 12 seeds are planted, what is the probability that exactly one doesn't grow? So if we approach a probability problem, we have a lot of different techniques available to us to try and solve it. One thing that would be nice is if we were able to use a distribution to solve it, because those are very systematic in how we solve these probabilities. Notice here that we have a seed that's planted, and either it's going to grow into a healthy plant or it won't. So there's only two things that can happen, which hints at a binomial distribution. Another thing that we have to make certain of is we have a fixed number of trials. So we have 12 seeds that are planted. So there's our fixed number of trials. And we have to make sure that the trials are independent of one another. So if one of the seeds grows, that doesn't really affect the probability that the next seed grows. So I think we can easily assume independence here. Okay, so the binomial distribution, it requires two main inputs, n and p. So n is the number of trials, so we're planting 12 seeds. P is the probability of success. So there's an 80% chance of growing into a healthy plant. But be very careful, because we're looking for the probability that exactly one doesn't grow. So the probability that one doesn't grow, well, if the probability that it grows is 0.8, then the probability of one seed not growing, is complementary to that, which is 0.2. So be careful there. So we're going to make sure P matches the event that we're interested in. So just be careful. Sometimes they switch things up like that on you. Okay, now we have the number that we would like to observe out of the 12. So we want the probability that 1 doesn't grow out of the 12. And so x will be 1. Now, you might be thinking, why wouldn't the probability just be 0.2? Well, the reason it's not 0.2 is because that would be the probability that one seed out of one trial doesn't grow. But we have 12 different trials, and there's only a 20% chance that it doesn't grow on each individual trial. So if we had 2, we would have 0.2 times 0.2, which would be a much smaller probability. So that we have multiple seeds that we are observing changes the probabilities. But we decided this is a binomial distribution. We have two functions that we can work with, Binompdf and Binomcdf. And anytime you see the wording of exactly a certain number of outcomes out of our sample, then that's telling you we would use Binompdf. Binompdf accepts 3 different inputs: the number of trials, the probability of success on any given trial, and x, which is the number of successes that we wish to observe. So n is 12, p is 0.2, and x is 1. If I put this in the calculator, go to the second nvars key, which brings us to the distributions menu, and then come down to where we find binomial distributions. Notice there's Binomcdf and Binompdf. Choose the appropriate one for your situation. 12, 0.2, 1. And we get our probability, which in this case is 0.2062. And of course, follow the rounding rules given in the problem. I've just chosen 4 for this particular case.